I would like to introduce the runtime type checker system, and for this I prepared 3 tabs. The first tab is the demo app, which will trigger all the type bugs that we shall investigate. The second tab is an illustration in a nutshell of this kind of type bug. And the third tab is basically a live demo for everyone to test for themselves. So we start off by adding a button, and for some reason that we don't know yet, it is triggering many type errors. And if we remove the buttons, we generate another kind of error. We can start with the remove errors because that's easier to understand. So for this we can click on the warning, and this prints the entire stack trace that led eventually to this warning. And if we want to investigate that, then we can set a breakpoint. The system is basically inserting type assertions. So, and if it fails, then you can add a breakpoint here. This was triggered by removing buttons, so let's add another button and remove it. And now we have the first kind of type bug. It is setting a mesh, but the value that was given is null, which is okay. In the engine, it's made for it. But the thing is, from the type perspective, this is an error anyway. But this is a kind of type bug that is not a huge deal, so maybe we can just forget about that. Press F8 to continue. And now we can investigate the other kind of bug. We are adding a button. This is creating these type errors. And then we can just start from the beginning maybe and go to set positions. And we can inspect this assert type, and you can add a breakpoint here. So let's do that and add another button. Okay, now we see that positions is an array supposedly of these kinds of types, and in the engine number array is used. But there is something wrong about this type. In particular, if we look at it, it has the length 108, but it has no values. So this can never work out, even though TypeScript itself does not even warn you about this kind of bug. So I would like to introduce the bug in the second tab now. We can just press F8 to continue here. And this is the type bug in a nutshell. We can just change it here. And if we print this code, then it does nothing more than logging the numbers. And now we can do something else. We say the length is 20. And there is not one type error right now here. But if we execute this code, this is not a number array. This is basically either a number or undefined. And this is eventually what triggers the type bugs here, which we will investigate a little bit further later. So, how does my system help to fix this kind of bug. For this, we can go to this live demo and we can change it here. And if we press Shift Enter, this code is translated into this code, which basically does the type assertion, and then it just prints warnings to the console. If we execute the right side with Shift Enter, we see basically the numbers are printed. No error, perfect. And now we add the same mistake, so to say, to this code. Press Shift Enter and press Shift Enter on the right side to execute the transformed code. And now our system is warning you about this kind of type bug. So now we can see how we can solve the issue in the PlayCanvas engine by understanding the background of this kind of bug. For this, we can add a new button. And we can basically just click on any warning, because they are related, and then go to, for example, create text mesh. And create text mesh is a little helper function which does many things, like creating the mesh and then just setting the positions, normals, colors, and so on. So we just hit the breakpoint and add another button. Okay, so now we can inspect everything in detail. And here we go. We have a number array for colors, outlines, positions, shadows, and UVs that have a length, but they have no values. So what we can do now is to search this code in the engine itself, which is the debug build here. And then we can inspect. For example, we can write mesh RRBB, AA, the axis aligned bounding box, is mesh AABB, and we only really care about the center right now. So every time we are adding a new button, we should see that message, but we need to reload it once more. Okay, this was actually not the right method. Yes, this is the create text mesh function. So what we can do here is to print the center of the axis-aligned bounding box. And every time we are adding a new button, we are getting the problem with not a number. So this kind of type bug is basically messing up the vector 3 inside the bounding box. And what happens internally we can investigate by adding a new button. And then we go into vector 3 set. We can add a breakpoint here. And if we add a new button, we are calling this vector 3 set with the values of undefined 6 times altogether here. And this does something to the vector. Which I can maybe better present in a little example. We are basically doing test set. So we are calling it with 3 undefined values, just like in the engine. And now everything this vector is about is basically wrong. It turns into not a number because it is undefined. And if we do something like cross it with itself, then the entire vector is not a number. So usually you start with undefined and then you multiply or add or subtract from it, and then it turns into not a number. And this kind of error can possibly perpetuate itself through the entire engine until the camera crashes or it's infecting, so to say, entities, because everything you multiply with not a number, it's turning into not a number. So I think it's very important to detect these kinds of bugs in the engine really ably. So we can add one more button and see how to actually fix this bug or where it originates from. We can basically just walk down the stack trace for doing so. For example, update text maybe. And we can look at the code in Visual Studio Code so we have a better overview. So we are creating text mesh with the mesh info, and the mesh info is using these informations and leading it into mesh. But we have seen that positions, for example, it has our lengths but no values. So this eventually fails, for example, to calculate the axis-aligned bounding box of the mesh. We can use Alt left to go back, and then we scroll up a little bit, and here we can see how mesh info indices and normals are set. And now we are getting to the position which actually is causing this kind of bug. Mesh info positions lengths is set to the normals length, and the value is undefined. In order to fix this bug, you have to fill the array, and this is basically done with the fill method of the array. Since we have indices and normals, we need positions to fill, and these 4 down here. And then we can basically just say mesh info fill 0. And if we have a proper numbers array that is filled with 0, this can go into create text mesh. And then the mesh info positions goes into set positions, which then can do its job in the set vertex stream. We don't need to investigate all this. We just see that the code flow for this specific number array is guaranteed to be not undefined. So we saved it and reload the engine. And now we can see that the center is not a number anymore. So we can add a new button. And every time we are adding a new button, the entire page of type errors is fixed. And we can be sure that the axis-aligned bounding box calculation, for example, gives a proper vector 3 for the center. And this guarantees if there would have been any calculation using this axis-aligned bounding box, then it would not infect or perpetuate itself throughout the engine. So I have shown that catching type bugs is only really possible at runtime, because TypeScript simply cannot detect it. And the runtime type checker system does exactly that. I thank you for your attention.